Hi all, this is Lakshmi, working as assistant professor in the Department of ECE at SNSCT. So today I'm here to discuss about the lecture series on smart sensors and devices. And the topic I'm going to discuss here is about the measurement of displacement using potentiometer. So first, let us discuss about the term displacement. So displacement means it represents the change in the position of a point with respect to a reference point. And normally this displacement is a vector quantity because as it has both magnitude and direction, we call the displacement as the vector quantity. So it gives the difference between the coordinates of the 2 points. So it is having both the direction as well as the magnitude. So displacement means it refers to the change in position of a point or a body with respect to the reference point. So here we are going to discuss how this parameter is measured with the help of the potentiometer. So displacement the purpose of this is it is used in variety of IoT applications where we measure the displacement in the application. So why we measure displacement? As I told, with the help of this parameter, we can calculate other derived quantities like force, stress, pressure, velocity and acceleration. So that is all these parameters can be measured in terms of displacement. Hence, we measure this parameter displacement. So we could see it is the distance change in position from one point to the other point with respect to a reference point. So that you call it as a displacement. And talking about this displacement transducer, what it actually does is it is going to convert one physical quantity into electrical quantity. So here we could see that there are two parts. One is sensing element and the other one is your transduction element. The sensing element is our primary transducer and transduction element is our secondary transducer. And finally, the conversion, the physical quantity is getting converted to a electrical signal. So now let us discuss what exactly is potentiometer. So potentiometer means it is an instrument. It is also called as a variable resistance or we call rheostats, which means we can vary the resistance. Through that, we can calculate the unknown voltage by comparing it with the known voltage. And it is a three-terminal device which is mainly used to calculate the potential differences between the terminals. And the known voltage here can be calculated by the cell or any other supply sources. So normally potentiometer is a form of variable resistance. It is a three-terminal device with the position A, B, C, where center one B will be a movable part, which we call it as wiper or slider. So there are two types of potentiometer. So one is linear potentiometer and the other one is angular potentiometer. So first let us discuss about linear potentiometer. So in case of linear potentiometer, we could see that the resistive element or the wire, resistive wire or element which we have taken will be in straight line. So that it is called as linear potentiometer. So this is basically a potentiometer with three terminals A and C, and B is a contact point which is acting as a slider, and the object whose displacement has to be measured is connected to this slider. We also call this as wiper, contact point B position, and the output would be taken from the points A and C. So this is having sliding contact as well as the that which moves over the length of the resistive element, which is a straight wire in linear potentiometer. And this contact connects to the plunker and which is linked to the object whose displacement is to be measured. So the equivalent electrical circuit of the linear potentiometer is given here. So referring this circuit, the input voltage here is Xt, which is applied across this whole resistance, that is point A and C, and the output voltage Xi is measured between the sliding points B and at the end of the point C. So here a linear relationship exists between the input voltage xt and the output voltage xi and this distance bc. So with the help of this slider, as this moves, there occurs a change in the resistance which is taken as a change in the voltage at the output, through which the movement of the object can be calculated with the help of this potentiometer. So the mathematical expression here, there is a linear relationship here. So voltage per unit length is E by xt and the output voltage would be calculated as xi by xt with respect to E. So next is angular potentiometer. So this here the resistive element which we use will be of circular, the resistive wire would be circular line. So rotational motion can be measured from few seconds to 360 degree. So this type of potentiometer we call it as rotatory or angular potentiometer, through which we can calculate the angular displacement. So the today's assessment is what is the fundamental principle behind the displacement measurement using a potentiometer. So as we have discussed, the voltage drop across the uniform resistance wire will be directly proportional to its length with a constant current flowing through it. So through the change in the voltage, we could calculate the displacement of an object. Thank you.